Good evening, pre-calculus students. I want to go over the recent quest you took so that you are aware of some small things that were the more common errors made, so that those can be remedied before we take a test on the same material in the coming weeks. So let's just start right at the beginning. Here's the quest. You've all received marked up versions of it back. I apologize for how crude my markups are. I'm using an iPad that I don't have a good stylus for, so it's hard to do it well with just my fingertip. Anyway, here's a nice clean version of the answers. This first one, you have to use some of these geometry facts you have learned in the past to help you get the interior angles of this triangle correctly identified. Knowing this is a right angle over here, that's enough to know that this inside angle of W is 49 degrees, that's 90 minus 41. The angle E, which makes up the angle in the triangle, is the 90-degree angle plus the 21 degrees that's here. That's 111 for the angle that's here. And if you take those two away from 180, you get 20 degrees for the angle up here. That's you need all those angles to help you then use law of sines to find x, the unknown side. Here's the correct, most efficient way to do it. You have both angle B and the side opposite it, so that's one of your ratios, and you're going to set that equal to sine of 111 over x, because that 111 is the angle opposite x. Doing the math, you get eventually x equals 431.278. The directions set up here round all decimal answers to 3 places unless otherwise indicated, so that's why we are going to 3 decimal places. This next one, I think most of you got that it was 0 triangles, but I did sometimes take off credit if your drawing wasn't good. When there's no triangle possible, your drawing should not show a triangle. It's impossible. A lot of you found out that the height was 9.548. Based on just doing the sine of what would be this right triangle right here. Or you could do law of sines and you get to the point where you have sine of C equals 1.5913, which is sine's never greater than 1, so there's no triangle. You can't get an angle for C. Both of those allow you to conclude there's no triangle. The reason here is the height is greater than the side opposite angle B. You cannot, even if you tried to go straight down, a side measuring 6 will never reach this side here. I have a C here, but there's nowhere to put it because I can't get a side measuring 6 over to this side if this is fixed at 43 degrees. I also want to say something about triangles. You don't always have to put A in the corner. I like to put the angle I'm given right here. And then 14 is one of the sides that makes up this angle because it's opposite C. And that would put A up here. C would be along here if we had a triangle. We just can't here. So please make sure your drawing shows the situation. On page 402 of your book, I'm going to quickly move the camera over there. Here's the book. Here's page 402. There's a really nice diagram showing the different cases and good drawings that go with them and what's going on with the different cases. So your drawing for a no triangle situation, it looks like either this case or this case. We haven't done many that look like this. In our case, ours is more like that. There's different ways you can arrange things, but the problem is we just can't draw a triangle. So you shouldn't show me a triangle. Now on to page 2. Here we go. So here's the one at the top, also a how many triangles question. You don't have to solve the triangle as much as do enough math to make your conclusion. Here's my drawing. Some of you lost 2 points on this one for not showing me 2 triangles. If you got the right answer and did some of this math, I gave you 5 points, but if you didn't show me 2 triangles with two sides measuring 22 coming off of B, getting down to this side here, then you didn't get full credit. Several of you did show me 2 triangles, so that was good. So the math, in this case, if you did use law of sines, you would eventually get that angle A could be 63.59, roughly, that would be this situation. That means there is an angle that works. A 63-degree angle is an acute angle, so this is the way this side measuring 22 would go. But since 22 is less than 25, I can also draw a side measuring 22 that goes this way. This angle here is acute, and inverse sine will never give you that when you do this step using inverse sine. But you have to think using your geometry brain to say, okay, when this is 22 is less than 25, there's actually, I could tuck this side measuring 22 in here. I hope this looks shorter than 25. This is an isosceles triangle in here. But this is the case where you have two triangles, where you do get an acute angle out. It means, well, you can get an acute if it's really long, but then if this is less than the side right here, and it's making up, one side's making up C, then you know you can draw a second triangle. So one of these this says A sub 2 and this says A sub 1. So A sub 1 BC is a triangle that works, and A sub 2 BC is a triangle that works. So just please, the directions said make a drawing. You should make a drawing that matches the situation and show me both triangles. This problem, there were generally not problems with it. You guys, I think, largely got D as the correct answer. You're plugging into the formula correctly. Let me make a comment about drawings real quick. I like to do my drawings as close to the sizes as possible. So like here I drew a 58-degree angle. That's roughly almost a 60, so it's not that small, but it's not over 90 obviously. And the side measuring 10 I made looking less like it was a lot less than a side measuring 21. Up here I drew an angle that looked sort of like a 52-degree angle. It helps your drawings if you actually just ballpark close to what the measurements are. Moving on here, this one there weren't many problems either. When they say, can you make a triangle, there's different situations where you can make those decisions. If this was like a side, which one was this? A side-side angle, which is the one that could be ambiguous, but this is a side-side-side. There is a geometry fact that two sides of a triangle always add up to more than the third. If you think about that, if I asked you, can I make a triangle with sides measuring 1, 2, and 5? You could not, because 1 and 2 add up to 3, and there's no way you could arrange a side measuring 1 and 2 to make a triangle with a side measuring 5. These can easily do it, and there's a triangle that could have those lengths, and then you use the formula indicated in directions to calculate the actual area. So that came out to be B. Okay, finally, the last problem here was generally well done with some small calculation errors. If you don't show me much of your intermediate steps, even if you're doing most of it on a calculator and you punch in something wrong, I'm going to have to take more than a half point if I can't see what went wrong. A couple of you lost a point here and there, or sometimes more if you just showed me too little. I don't mind you using a calculator, but you got to make sure you enter things correct. So anyway, everyone got this off to the right start. If you didn't get this answer, it was because something was plugged in wrong. Again, I rounded to 3 decimal places because the directions say unless indicated, you need to round to 3 decimal places. So that's why this is to 3. After you use law of cosines to get this going, because when you have angle, side, law of sines won't help you, so you have to use law of cosines to start the problem. After that, you can use law of cosines or law of sines. My solution shows finishing it with law of sines. To get angle B, you would get something close to this if you used law of cosines. You could also found angle C next and not angle B. Whatever one you get, then at the end you take 180 minus 125, the angle given, minus the angle you got here. A couple of you accidentally used this as to subtract for angle A and got a weird answer. You have to be careful. That is not an angle measure. That is a side length, and you should be using angles in the triangle here to find out the third angle. So that's it. Just take note of those comments I made so that if you made any of the errors I talked about, you'll remedy them in the future. Thanks.